तो स्टूडेंट्स आज ये वीडियो पे हम लोग डिस्कस करेंगे सेल्स इन सीरीज एंड सेल्स इन पैरेलल। ये चैप्टर 3 करंट इलेक्ट्रिसिटी का एक टॉपिक है। सो आज ये दोनों डिस्कस करते हैं, पैरेलल केस और सीरीज केस डिस्कस करते हैं। रजिस्टर इन सीरीज एंड रजिस्टर इन पैरेलल आल्सो, दिस इज अ पार्ट ऑफ दिस चैप्टर, योर चैप्टर नंबर 3 करंट इलेक्ट्रिसिटी। बट ये क्लास 10 में आप लोग मतलब ऑलरेडी डिराइव कर चुके हो, तो इसीलिए उसको अभी डिस्कस नहीं कर रहे हैं। पर कमेंट इफ यू रिक्वायर द डेरिवेशन फॉर दैट आल्सो, कमेंट in this video, so I'll make another video for the your register in series and register in parallel. तो आज इस पे सेल्स इन सीरीज एंड सेल्स इन पैरेलल ये केस डिस्कस करते हैं। तो सेल्स को हम सीरीज में कैसे लगाएंगे ना, पॉजिटिव नेगेटिव फिर पॉजिटिव नेगेटिव ऐसे लगता है, तो वो सीरीज में वी connect the cells in series like this way, positive negative। तो ये केस पे हमारे पास जो टोटल वोल्टेज कितना होगा ये दोनों सेल के लिए, तो टोटल वोल्टेज कितना होगा। अभी क्या करेंगे ना, हम ये सेल्स का इंटरनल रेजिस्टेंस को भी कनेक्ट कंसीडर करेंगे। ऐसे नहीं कि इसका वोल्टेज दोनों सीरीज में लगा ऐड ही कर देंगे, इसका इंटरनल रेजिस्टेंस को भी हम लोग कंसीडर करेंगे। लेट्स से इसका EMF E1 है, इसका EMF E2 है और इसका इंटरनल रेजिस्टेंस R1 है, इसका इंटरनल रेजिस्टेंस R2 है। ठीक है, तो इंटरनल रेजिस्टेंस कोई भी सेल का रहता है, उसका आउटपुट वोल्टेज टर्मिनल वोल्टेज क्या बन जाता है। सपोज कोई एक सेल है ऐसा, उसका EMF E है, इंटरनल रेजिस्टेंस R है, व्हाट विल बी द आउटपुट वोल्टेज अक्रॉस दिस। सो आउटपुट वोल्टेज V इक्वल टू, सपोज करंट I इज फ्लोइंग हियर, V equal to E minus IR. That means IR amount of voltage will be dropped by the internal circuit or internal resistance. Okay, so this amount it will be reduced from the EMF, the maximum potential of this battery. Suppose this is a 6 volt or 9 volt battery. Now due to the 1 ampere current is flowing and resistance is also 1 ohm. So that means 1 volt will be reduced from the terminal voltage. If you connect a voltmeter here, you will not get 9 volt due to the internal circuit internal circuit will reduce the voltage. What amount? Let's say I equal to 1 ampere. So 1 into R, that is 1 volt will be reduced. So output voltage, the voltmeter will read that 9 minus 1 volt, so 8 volt you will get the as the terminal voltage. Are you getting the difference between EMF and volt? If there is no internal resistance or close to internal resistance is close to 0, so your EMF will be equal to your also terminal potential, right? Potential difference. So this is the relationship between V and EMF, potential difference and EMF, electromotive force. So this is the EMF of the cell, that means the maximum potential. Here EMF for this cell 2 and having resistance 2. So this is a positive, so current will flow like this, and this is positive current, same current will flow because they are in the same series, same conductor. If there is no junction, then same current will flow, right? If there is a junction, from Kirchhoff's rule we can say that the current gets divided, right? Current will be divided if there is a junction. If there is no junction, same current will flow. The same current is flowing, right? If same current is flowing, let's say the point A, this is point B and this is point C. So what will be the potential difference across VAB? VAB will be your E1 minus IR1, and what will be VBC? This one VBC will be E2 minus I, same current IR2, and this one, this diagram is for what? This one we are discussing for the your series case. The cells is connected in series. So this is the case of, first we are discussing the case of cells in series, right? So now what we'll do, we'll just add this voltages, right? So VAC means this VAB plus VBC. So VAC we will be getting, that is the potential across this one. So this and this cell will be added. So we will add this and we will be getting E1 plus E2. We'll add, and if we'll add this part, it's minus IR1 minus IR2. Now E1 plus E2, right? E1 plus E2 minus you take common, I you take also common, same current, that R1 plus R2. Now you see this is the voltage across the combination, that VAC. Now also we can write that V, this combination AC equal to, we can write, right, from here, that VAC also, that E equivalent potential of this one, E equivalent plus I into R equivalent, this internal resistance equivalent, IR equivalent. Now if you compare this equation with this one, we can see that what will be your EMF? Your EMF will be, equivalent EMF will be, in case of series, just you have to add the individual EMF. So two cells are there, so we have taken 2. If more cells also will be there, let's say a number of 10 cells are also there, you can keep on adding this, right? If they are connected in series, like positive negative. So this will be the EMF, equivalent EMF, and what will be the equivalent resistance if they are connected? Their equivalent resistance will be, R equivalent will be, like their internal resistance are also in series. So you can see that a series formula is coming, R1 plus R2. If you compare I, R equivalent, so this one is your R equivalent. This one is your equivalent resistance. That means, because you can see that R1 and R2, they are internal but they are in series. If they are series, so R1 and R2, because we know that if resistors are connected in series, so the result will come up R1 plus R2 plus R3, like that RN. So here also we are getting, हम लोग को मिल रहा है कि R1 plus R2 ऐसे करके मिल रहा है, और n नंबर ऑफ रेजिस्टर्स होगा, R3 R4 R5 ऐसे होगा, तो और हम लोग ऐड करते रहेंगे. तो ये हो गया सीरीज केस. अब डिस्कस करेंगे पैरेलल केस. सेल्स इन पैरेलल. Cells in parallel case. So cells parallel कैसे रखेंगे? How will you connect cells in parallel? दोनों का पॉजिटिव टर्मिनल एक होगा, दोनों का नेगेटिव टर्मिनल एक होगा. इस टाइप का कॉम्बिनेशन को हम बोलेंगे सेल्स इन पैरेलल. जैसे पॉजिटिव नेगेटिव, इधर हियर आल्सो पॉजिटिव नेगेटिव, दोनों का पॉजिटिव से कॉमन टर्मिनल आएगा, नेगेटिव से कॉमन टर्मिनल आएगा. दिस इज द केस ऑफ ए this connection. Another cell also you can add, you can keep on adding n number of cells in parallel, right? So this will be the case of a parallel case. Now the cells are connected parallel, so its EMF is E1, its EMF is E2, and this one internal resistance is R1, this internal resistance is R2. Okay, so now this is the your positive terminal. So this, if this is positive part, this is the positive part. So what will be the direction of current? This will be the direction of current, and for this one also current. Let's say I1 current is flowing here, because the branching is there, so we cannot say that same current here and here it will flow, because there is a branching. So let's say the current is flowing here is I1, current flowing here is I2. So here the current will add up. Let's say I current is flowing together, because these two currents are coming, and at this junction they are added up and they will give I. So the condition we can write that I is equal to I1 plus I2. We can write this condition because I1 plus I2 is our I. You can see the junction and you can see, and towards the negative the current also will go. So you can do draw the diagram like this. So diagram should be there in for your board exam if the question comes. I think this year also this question come, that derive the expression for cells in parallel. So this question comes regularly, or a numerical will come. Numerical will discuss in the later classes. So let's say this point is your AB, and this junction points are, let's say, B1, B2. So the potential across B1, B2, that means V will be same for both upper circuit and lower circuit, right? So B1, B2, the potential V will be same for here and here. So we can write that what is the potential? B equal to whether it is E1 minus I1 R1, we can write the upper circuit. Lower circuit also same potential will be there because common terminal is same, so that's why the potential will be same. So that's why the lower terminal if will go, then V equal to also E2 minus I2 R2. This way also you can write. So from here, let's say if you want to write this one, so what will be your I1? Just bring it here. So I1 will be I1 R1 will be E1 minus B, or your I1 will be E1 minus B divided by R1. So now we can put here that your I is equal to E1 minus B by R1 plus E1 minus B E2, that I2 is E2 minus B, same potential, by R2. You will simplify this. So this is your current. Now we are interested to find the total EMF. What will be the total EMF? So how will you do that? Now we will further simplify this. We will further simplify this and we will be getting the expression. So what we will do? Now this is your I. So I equal to, it will be E1 by R1. Simplify it. And this will be E2 by R2, I am bringing close to it. E2 by R2 plus minus, this B is common, let's say minus B is there. So it's 1 upon R1 is there. And here 1 upon R2 plus 1 upon R2. Okay. So this is what we are getting as your current. Now we'll simplify further. We'll simplify further. So what we'll write? Our I is E1 by R1. So LCM will be R1 R2. So it will be E1 R2 plus E2 R1. If we take the LCM, and if you will, this part if will bring to the left, ये पार्ट को लेफ्ट लाओगे और ये आई को राइट ले लोगे तो क्या हो जाएगा? तो आई को राइट ले लेने से ये माइनस आई बन जाएगा और वो उस पार्ट को लेफ्ट में ले लेने से वो बन जाएगा v इंटू 1 अपन R1 प्लस 1 अपन R2, ये हो जाएगा। और v इक्वल टू क्या होगा? v इक्वल टू ये डिवाइड हो जाएगा, ठीक है, डिवाइड हो जाएगा इधर, और इसको हम सिंप्लीफाई कर देंगे तो क्या होगा? इसको हम सिंप्लीफाई कर देंगे तो v ये हो जाएगा R1 प्लस R2, इसका एलसीएम लेके R1 R2 एलसीएम R1 प्लस R2 इक्वल टू E1 R2 प्लस E2 R1 बाई R1 R2 minus I. Now I'll multiply this one, this side, cross multiply. So my V will be what will be my V? It will be multiplied. So it will be E1 R2 plus E2 R1 by R1 R2. If this I'll multiply here, means this one whole quantity will be divided here. So R1 R2 will be numerator now, and R1 plus R2 will be the denominator, minus this one also will be multiplied here also with I also. So I into R1 R2 by R1 plus R2. So now this R1 R2 will cancel out. So what B you are getting? B you are getting E1 R2 plus E2 R1 divided by R1 plus R2, and this part you are getting I into R1 R2 by R1 R2 by R1 plus R2, right? So this one again we can write similar equation, that here we are getting the expression that V is equal to E equivalent minus I into R equivalent. In this term it should come. That means this part should be your E equivalent and this part is your R equivalent. Okay? So this part is your E equivalent. So what you can write for E equivalent? Your E equivalent equal to, right? Your E equivalent will be E1 R2 plus E2 R1 by R1 plus R2, and your R equivalent will be R1 R2 by R1 plus R2. So if I further simplify, I'll just divide E RQ E equivalent by R equivalent. Okay, so 1 by R equivalent is what? This one. So if I'll divide it, what I'll get? Means I have to multiply. So E1 R2 plus E2 R1 by R1 plus R2, and you have to multiply this one. R equivalent divide, that means denominator will be R1 R2 and numerator will be R1 plus R2, reverse of this one, because it's in the denominator dividing. So R1 plus R2 cancelled out. So what is there? Just if you simplify, what you will get? What you will get? Okay, markers. Okay, so what you will get here? So you will get E1 R2 by R1 R2 plus E2 R1 by R1 R2. R1 cancel, R2 cancel. So basically what you are getting for cells in parallel, you are getting for E equivalent by R equivalent. So the result you are getting that E equivalent by R equivalent equal to E1 by R1, okay? E1 by R1 plus E2 by R2. This is what you are getting for E equivalent, one relationship, E equivalent by R equivalent. So suppose two cells are there, more number of cells will be there, E3 will be there, like that. If keep on adding the cells in parallel, so what will happen? More terms will come, E3 by R3. So this is how you will get the E equivalent. Now R equivalent, we got this one, and if you want to write in 1 by R term, so 1 by R equivalent will be, this one will be reversed, that is R1 plus R2 by R1 R2, or you can write 1 by R equivalent, 1 by R equivalent equal to, it divided, that is 1 by R1 plus 1 by R2, or 1 by R2 plus 1 by R1, that is same as 1 by R1 plus 1 by R2. So this is what you will get 1 by R equivalent, and this is what you will get E equivalent. Okay, so this is the derivation for your cells in series and cells in parallel, which is has some importance for the examination, especially for the board examination, and you should know the derivation, that how we are coming to, even if you are preparing for JEE and NEET. So because you should have a confidence that these formulas are derived like this. So if a situation given to you, right, and the answers are like this, you should be able to derive also. Sometimes the questions are not just numbers, you will put the value and get the answer. Sometimes they will give a situation like this, and they will ask, the options will be given like this only. That means if you have forgotten or some new situation will be given, you have to derive it. Ultimately you have to derive, you can't skip the steps. So there is no other way, right? So in that case you have to यू शुड नो द हाउ द डेरिवेशंस आर डन। ठीक है, तो ये सब प्रैक्टिस कर लो। फिर नेक्स्ट क्लास में हम लोग ड्रिफ्ट वेलोसिटी भी इस चैप्टर का इम्पोर्टेंट है, तो उसको डिस्कस करेंगे। उसके साथ किरचॉफ्स लॉ डिस्कस करेंगे, किरचॉफ्स योर लूप लॉ, करंट लॉ, योर जंक्शन रूल एंड लूप रूल, ये दोनों डिस्कस करेंगे। उसके बेस्ड पे व्हिटस्टोन ब्रिज डिस्कस करेंगे। और इस चैप्टर का जो टेम्परेचर डिपेंडेंस, रेजिस्टिविटी, ये सब पार्ट भी डिस्कस करेंगे। 2 to 3 लेक्चर्स क्लासेस लेंगे इस चैप्टर का, तो करंट इलेक्ट्रिसिटी पूरा चैप्टर 3 कंप्लीट हो जाएगा। थैंक यू फॉर वॉचिंग, सी यू इन द नेक्स्ट वीडियो।